Have one of those terrible, terrible dreams and wake up wondering why there aren't puppy-sized spiders? These days, the largest insect on record is the giant weta of New Zealand, which can grow up to 10 centimeters long and weigh around 70 grams. About the size of a small bird. But there was a time when bugs were very different. 300 million years ago, insects like the Meganura dragonfly, with wingspans 65 centimeters across, used to fill the skies along with the other insects like 8 times bigger than the ones that we have today. So why then and not now? Well, John Harrison, physiologist at Arizona State University, knows probably more about this than anybody else, so we asked him. And our first question was about the most common theory regarding insect size. For a long time, experts believed that the weight of an insect's exoskeleton was what prevented it from growing too much larger. However, Dr. Harrison said that there aren't a lot of facts to back that up.
And so people have argued that really having an exoskeleton is not compatible with being large. The interesting thing is really there's very little data on that, and the data that there is doesn't really support it. Probably the one thing that supports that idea is the fact that in the sea we get much larger arthropods than we do get on land, and of course in the sea they don't have to support their bodies.
Harrison also pointed out that the proportion of exoskeleton to body size is the same in large insects as it is in small insects, so the exoskeleton idea sounds kind of like a non-starter. So what else you got, Doctor?
Another idea that's been put forward, and that's really been something that we've worked on a lot, is this idea that relates to oxygen delivery. So insects breathe in an entirely different way from humans. They have a series of holes along their side of their body, and then the oxygen comes in through these holes and goes as a gas in air-filled tubes. And these tubes branch, kind of like the branching tree, and get very small, down to in the range of a micron in size, so really tiny, and can get down close to every cell.
These tiny tubes are called tracheoles, and they dead end in the body cavity where oxygen diffuses into the insect cells. Dr. Harrison says that this could be a limiting factor for bugs' growth. In large insects, tracheoles would probably have to be really, really long, which would make the diffusion of oxygen difficult. But that might only be a problem given the oxygen levels we have in the atmosphere today. Another theory is that giant insects were possible in the past because there was a lot more oxygen in the air.
And that idea has gotten some recent support from geologists who showed that in the late Paleozoic, atmospheric oxygen rose to well above what it is today. Right now it's 21% oxygen. In the late Paleozoic, we think it was about 32% oxygen. And that happens to coincide with when we had much larger insects than we have today. And so that kind of has boosted this idea that oxygen delivery is what keeps insects small, and that higher oxygen in the atmosphere could enable them to get there.
In the end, Dr. Harrison says we don't have definitive answers, only theories. But whatever the reason is, I for one am happy with bugs staying the size they are. In fact, if we could get them a little smaller, I wouldn't mind. If you have any questions for experts, we are happy to try and find experts to answer them for you. So let us know those questions or any other ideas or comments you have in the comments below or on Facebook or Twitter, and we'll see you next time.